So where should I start? Yes, okay, let's start with creator, Tung. So Tung is the founder of organization Vault Ops consulting company focused on AWS, and he is also AWS Community Hero focusing on containers. What it means is that he has a lot of videos. He has a lot of videos on YouTube where he talks about all his projects, and now you will understand why he's doing so many projects. I have been discussing with him a few things here and there. I can just tell you that he's pretty unusual guy, because as often with technologies, you start when you need to fix something, you just start working on it in the easiest way possible. So you pick technologies which you already knew from the past, and then you somehow connect them together, and then you think that it's good enough. So you kind of employ your previous knowledge and try to build something what is better than before. That's exactly what is happening with this guy, with Tung, because his experience in Ruby is insane. And amount of projects, let me just show amount of projects which he has been developing, and you will understand what I mean. Well, he has actually a homepage. I think it homepage lists even more projects, but let's see, just not sure what it means, not much views, unfortunately. Azure DevOps like build platform, not much views, unfortunately. Well, that's problem probably of Azure DevOps. No, I'm kidding. I don't know what is the problem with Azure DevOps and Klondike of knowledge. Yes, he is. Okay, so let's go back. So yes, he is creator of Terraspace, which we're gonna to talk about, Jets, Lono, Cubes, UFO, Kodi, and probably something more, because it just doesn't fit into this sequence. Right, yes, exactly. So the comment from Maxim was about amount of views. Yeah, that's just unfortunate, guys. Please subscribe to his channel, and I'm sure that you will learn just, I don't know, about anything. SQS queues with CloudFormation, here you go. Like I clicked on some like Lono CloudFormation framework, because there are 20,000 CloudFormation frameworks, but no, there is 20,001, because Tung has created one. And in general, yes, you're absolutely right. He has created a bunch of different things. So yeah, he has created Lono, UFO, because ECS is hot, and of course, yeah, of course, there are missing tools everywhere. So yeah, he has developed a bunch of things. So yeah, make sure to subscribe and to follow him. He has projects, and he has GitHub and Twitter as well. So overall, when I first go to his profile page, I see, okay, Ruby everywhere. So I was a little bit skeptical at the beginning, because I know that usually if there is a programming language, then people will do everything using this programming language. And when it comes to my experience with Ruby, I was actually developing in Ruby when Ruby on Rails started in about 2006 or 7, I don't remember. And when you have Ruby, your hands automatically start writing framework. It doesn't matter what you want to do, whether you want to do it or not. If there is Ruby, there will be framework. So that's pretty interesting. I thought, like, okay, so this guy does a lot. And then I saw Jets. I think Jets I've heard actually before, because when you hear about these projects and you scroll, and then you see Ruby and Lambda, that's like, okay, Ruby is not very popular language. among many tools right now. I mean, it's just usually treated as something from the last century. And when you see modern technologies and modern development techniques like serverless and AWS Lambda, and then you combine it with Ruby, this project usually quite provocative, at least. So that's pretty much it about Tung. Just make sure that you follow all of his projects. So now let's talk about what is actually Terraspace. Terraspace is one of his projects, and Terraspace definition is, okay, Terraform project. Well, of course, as you probably know, my previous experience with terragrunt is that I'm pretty well aware about cases when Terraform is not good fit, or when Terraform should be replaced with something bigger and something more flexible. And that's why I was using terragrunt for quite a long time, and I saw how it's beneficial. So when I look into Terraspace and when I talk to the creator for the first time, pretty much instant question was, so what's your opinion on terragrunt? And from my experience of using Terraspace for a limited amount of time, it's actually not a replacement for terragrunt. It's doing things slightly different. So in a nutshell, Terraspace, well, there are a lot of different introduction videos which I encourage you to check, but I will just tell very like small things about the workflow. So Terraspace is not replacing or is not doing anything extra than providing you an let's say an opinionated structure for your infrastructure repository, and let you to bring up infrastructure or bring down some infrastructure. So that's pretty much the main idea of Terraspace. So it will literally generate code, or it will not generate, but it will enhance Terraform code, put it into a specific location, and then it will run Terraform commands there. Sounds pretty much the same way as you may imagine about terragrunt. The only difference is that terragrunt does a little bit more magic behind. For example, when it comes to passing variables, so passing variables to that project, terragrunt does it through environment variables. Here it's implemented slightly different, and in general they do pretty similar things from user perspective, I would say. But Terraspace is very new, is pretty much like how to say, not the first project, but it doesn't have any legacy other than Ruby in it. So there is a question: with the depends on for modules resolved with Terraform 0.13, does terragrunt still sense to be used? Yes, it does. I mean, terragrunt is still necessary, and it is necessary for the situations when you actually want to control what you want to do. Let's say if you use depends on and you have configurations in one big, let's say in one main TF file, and you invoke many different modules, that's good that you can rely on depends on. If it works, then it's great. But in most cases, you don't want to manage all infrastructure as a whole. You want to be much more robust and work on specific subset of infrastructure resources. So that's why terragrunt is still doing something differently, which Terraform 0.13 or 14 or 15 will not be able to cope with. And yeah, and still principles of don't repeat yourself are implemented in terragrunt, and there are no direct intentions for Terraform to make this life easier, honestly. I mean, maybe there are some plans in someone's head, but I don't see them discussed anywhere. So we'll see, we'll see. Okay, cool. So now let's go to the code, because I was told that you guys like to see some code. Is it true? Or do you want to see some PowerPoint presentation? Okay, let me close some files because they're not relevant. And here is this. So here is this project. Yes, okay. Let me just close some files. Yes. So here is this project structure. I will just collapse it a little bit to show it. So Terraspace example. So the way how I started it, or actually let me explain what I will talk and what Tung will talk about. So the first thing which I want to show, I will just talk about structure of the project and how I used Terraspace and what it gave to me. There are pretty much significant amount of features and add-ons already inside of Terraspace, which are really cool. And I will ask Tung to show them in details, and actually he will be able to answer your questions. So please think about what is what do you want to know, or if there are any hot things which you just couldn't solve with Terraform or terragrunt, and you want to know if it is possible to solve with Terraspace and how, please let me know in the chat. Okay, so the first thing which I want to do is that I run command which was, well, what was the command? The command which I run, well, the command was which I run, it generated, it just generated project. So the project is called infra, and then it generated app and config folders. So these two folders are like pretty self-explained, I would say. There is not much to do inside of config in config folder, but inside of app folder we can see that there are two folders already. There are modules and there are stacks. And some of you, I actually assume that some people who work with me on different projects now see this and they think like, oh yeah, that's what we told you that we want to use in Terraform code, because people want to have separation between modules and places where configuration for these modules lives. That's why we always have separation, like we use terragrunt and then we use terragrunt HCL, where we just contain key values which we want to use. So here is similar concept. We have stacks. So stacks is like your stack is called demo, and then inside of demo you have full place where you write your Terraform code. So literally this is how you describe your resources. In this case it's gonna to use module bucket, which is located in local folder, but of course it can be any Git repository here or anything else. So think about this demo folder as something where you put your Terraform configuration literally 100%. There is no limitations, no constraint for you what to do there. And of course naming can be customized the way you want. Yeah, so there are some questions about this. I will try to answer as we go along. So talking about this folder, is really important to understand that there are no limitations what you put here. So here we resource random path and bucket, and this bucket is the only thing which we want to create. We of course have outputs, we have some variables, so that's pretty straightforward. And then we have another folder which is called modules. This is just an example of how this module can be created. So that's an example of local module, but we can use remote from registry, from anything. Again, in these two folders, there are no limitations which Terraspace imply or Terraspace require you to follow a certain instruction. So then after this, there is folder called config Terraform. And you can see backend and provider TF. As you can guess what kind of stuff you can put here. Again, it's just convention that there is file called provider TF. you can put anywhere anything you want. And then there is file backend, and this is where interesting parts start to happen. So this file is actually embedding Ruby templates, and I can almost hear some people say, "Foo, this is Ruby. Why we should mix these technologies?" So please be quiet and don't produce unnecessary noise until you see how it is actually used. So here is function which is called expansion is used, and there you can see favorite, or not favorite, but Ruby syntax, column account and column region, column env. These variables will be expanded into something, and again, if you know how it's done in terragrunt, that's pretty much the same stuff. Terragrunt use its own functions written in Go. Here it's using the same logic with replacement, but written in Ruby. So that's fine. And then we have provider, where we can define some provider configuration, but it's not necessary, it's just optional. So now we have to do something, right? How to execute it? Well, that's where a lot of interesting innovation, I would say, is starting to happen. The first one is when we look into a command which is called, I'm not familiar with commands yet, but a command called build, Terraspace build. Hopefully it will work, because it may, yes, okay, cool, now it's actually working as expected. So it says that building one stack, and if I go to Terraspace, well, there is column info, Terraspace info demo, demo is the name of the stack, and there I can see where build directory is, where cache directory, names, and so on. So here I can see that cache dir is the one which is actually containing all of this information. So here I can go to stack, and then stack's demo is actually going to be executed. As you can see, these files are copied from parent configuration, because they define how backend will be described, and provider configuration. And then we have main, outputs, and variables. Again, if you know how terragrunt works, there should be zero surprises to you so far, because that's exactly behavior of terragrunt. I think terragrunt had it since version 0.1 in 2016, so it's the same behavior, nothing new here. But what is already interesting here is that backend configuration is already replaced. So this information is my account number, which I use for this, and this one is also replaced, because that's how it was designed. So what I do now is that I have actually a code created inside of stack demo, and what I can do next is that I can actually create this stuff by running, well, by running up demo. So up and the name of stack. I have already created this infrastructure before, and as you can see, the whole folder stack demo actually self-containing. So if you are dreaming about using terragrunt and run it on Terraform Cloud, but you couldn't because terragrunt does some magic which is not natively supported by Terraform, and you cannot just replace 100% of terragrunt with Terraform, so then Terraspace actually does no magic in terms of setting variables and passing values from module to resources. And as I said, you can just commit this folder and run it through Terraform Cloud natively. It's kind of supported out of the box. So yeah, now I run Terraspace up demo, and as you can see, it also built the same code which I built before, but anyway, it rebuilt it. And then it ran Terraform apply and input false because it doesn't want me to prompt for inputs. And cool part here, which I don't know if it is visible or not. well, it's scrolled before, so I cannot see. But logs from this view, or from running different Terraform init commands, are usually polluted with a lot of information, and we don't need to see all of that information. So what Terraspace is doing is that it hides a lot of logs which are unnecessary for you to see, but you can always find them. They are written somewhere in files like this. So in temporary location, you can see logs there. So, which is pretty cool. So you actually get most of Terraform, and adding like some requirements and some extra features which Terraform cannot give to you is, for me, is pretty cool. Again, as I said many times before, is that I believe that this kind of orchestration should belong to Terraform in first place. But I don't see this happening, and I don't think that most of HashiCorp employees agree to me, because there are no direct intention to look around and say, okay, from now on we will make Terraform and then let's say up with dependencies, for example. I mean, there is no such command, but if there would be such command, then this command should run the same things what I just did with Terraspace up demo. So yeah, we'll see how it goes with the Terraform, but if we are talking about just Terraspace today, then I think it's definitely on the right direction. And also, if I mentioned for how long time this project has been in development, you will be pretty much surprised. I think it's a couple months. So, well, 2 months of work, and it's time already to show to people and ask for feedback and ask for different like how people feel about it, other than it's written in Ruby. So yeah, it's good time. Okay, let me focus on the last thing which I want to show before talking to Tung. So here is another command which is pretty cool. Terraspace up, or sorry, all graph. So if I run this command now, you will laugh. Well, yeah, actually you will not see it. Right, you will not see, because so what it did, it's kind of funny. It visualized my infrastructure relations, and I will just show it in the browser how exactly it did. So Terraspace graph. So dependency graph, if you know what is apply all, plan all, and validate all in terragrunt, that was the whole inspiration for this solution as well. So Terraspace support deployment of dependent stacks too. So you can deploy multiple stacks. It's already pretty well documented, and you can take a look on how it's done. What I just ran in IDE actually generated this kind of graph to me. But since I have only one stack, there were no errors. There were just one. No, so there was just one box without any errors, which is pretty useless to see. But when you have a lot of relations like this one, where C1 is dependent on B2, B1, and A2, I think it's pretty cool. And imagine that you have actually real names of stacks here, not just keys, but actually real names. You should be able to understand what is dependency graph and how it will behave. You can also visualize part of your graph. So for example, here you can visualize just targeted subgraph, which include A2 and B2. So that's why A2 and B2 are included into this graph, and that's visualized. And yeah, you can also do the same command, run Terraspace up. If you write Terraspace up and then name of the stage, you will spin up just one environment. But if you write Terraspace all up which is a little bit confusing, you will see actually more information. So a question which is quite relevant already by Maxime. What is the difference from Terraform Graph when we output into SVG? Well, there are two things. Terraform does not work with like outside of this folder, it will not be able to visualize. Here, all of your stacks physically live in different directories, so they have different state files, and they are pretty independent from each other. So Terraform Graph can do this only inside of one folder, inside of one state file. This is one thing. And also Terraform Graph output significantly more information, which in most cases is unnecessary. And if you run this command on anything more than hello world, you most likely saw how useless that output is. It's easy to impress people, and it sometimes, especially in early days, helped us to understand how this dependency graph is supposed to work and what is dependency on what. But nowadays, I don't think it's producing a lot of values, because it just it's not necessary. Okay, and the last question, which I think I can answer, please share some information on how to use template rendering. Well, no, sorry, I cannot answer this question. So we need to ask for expert help. So let me ask expert. Just let me see, where is our expert? Our expert is here. No. Yeah. So where is our expert? Tung, are you still with us?
Yes, I'm still with you.
Cool. So yes, we can hear you. Can you enable your video?
Oh, that might be useful.
Yeah.
Where's no, that's me sharing my desktop. Yeah. Let me figure this out real quick. Start video. Do you see me?
Yeah. Yeah,
Hey,
we can see you and hear you. Cool. So yeah, just some things. Well, there are so many interesting questions from people. That's pretty cool. I don't think I have received so many questions when I talked about terragrunt, because terragrunt is well known and people were like, oh yeah, what new can you tell us? And now we have you. So let's get started. Just when people are coming up with different questions, can you explain a little bit about how you start this project? Because it's hilarious.
Sure. So I run a consultancy company, so I do work for different people, and I had a project that come up and was like, okay, I need to use something like Terraform in order to solve this this specific issue for this project. So I was like, okay, finally, I'm going to start taking a look at what the rest of the world has been looking at Terraform, because I've been actually doing a lot more CloudFormation and some of these other tools that you kind of cover, which that was cool, thanks. So I started playing with Terraform a little bit, and just like most people, what I do is I go on Google, I search for Terraform and how to use it, and then different tools. Then I started playing around with it, and some of the tools out there, you mentioned some of them already, it didn't fit right for what I was trying to do. So I was just like, do I have to go through this pain, and all that? And so I was like, no, there's got to be a better way. And so I kept it that for actually a bit. And then I was like, okay, well, I've actually built some of these tools already. I think I need some, I think I know what I need. So I'll just try to start building it, right? And so, so I usually don't go off. I just want to explain that context, because I don't go off and go, okay, let's go build a tool just for the sake of building tools, even though I enjoy it. I build for specific uses usually, for whatever problem I'm trying to solve specifically, like real world problems. And then I usually actually try to not do the work. And then sometimes I actually do use other tools. You're a DevOps guy, so you have to use a variety of different tools in real life. So then I will usually use some other tool, and then I will usually sometimes even fork it and then modify it to my needs. Then hope, pray to the merge gods that they might merge their pull requests back in. But then what eventually kind of happens, I've seen this pattern kind of repeat it, is it doesn't do exactly what I need to do. It's just that a little annoying bit, And then I just got, okay, I'm just going to write a tool that does exactly what I need it to do. So that's kind of how the origin story, I guess, of Terraspace. I started working on Terraform because I had to do it for a project, for a specific project. And then after that, I was like, okay, I just need the tool to do what I need it to do. So that's when I started kind of working on it. And then one of my buddies actually was working with me during this project, right? Because I work with other folks. And he was like, so you're going to go create this tool, huh? and like, I think he was a little bit like, I would say like, it was like some big kind of task, right? And I was like, no, I've done a lot of these different tools before, so I think I kind of have a decent handle. So I started working on it, and then he literally saw it from like not existing to like being created, and he was like, and he gave me really good feedback. So I've been working with him, and he's just like, oh, maybe you should, change this folder to this, and then I've been kind of incorporating like most, not all, but most of the feedback. And then so I kind of been building out that way, and then he was just like, Tom, I think you've kind of internalized how to build these type of tools from doing it for so long that you just have kind of like some of the patterns down. So I think this is actually an aggregation. I'm kind of proud of this work of kind of a variety of different tools. Like you mentioned another tool I wrote called Lono. It's a CloudFormation framework. That's actually 10 years old, right? UFO itself is actually like 8 years old or something. All these other tools. And what I did was I try to grab the best ideas and concepts and then just kind of apply it back over. And that's why, you kind of mentioned like, oh, this is actually quite young, but it's quite young based on some kind of knowledge that just, I think if you beat into your brain long enough, eventually that knowledge is like, is stuck in your brain. You're like, okay, so I know not to do this, I need to do this. And so that's kind of the evolution, I guess, the origin story of Terraspace. Hopefully that was helpful. I felt like I kind of went on a couple of tangents there.
Yeah, but that's really cool to know. I mean, 10 years ago, come on, CloudFormation was just released 10 years ago. So yeah, that's it's pretty interesting, because my experience with CloudFormation and people who use CloudFormation is that pretty much instantly they figure out that there is need to do something. Spectre, Fog, whatever else people come up with was created to simplify work around that. And from my experience, people who use Terraform are almost never come up with anything more complicated or sophisticated than collection of shell scripts with just here and there do some ad hoc things. I have made my collection of ad hoc shell script myself, and then I figured out that I'm probably not doing something right. And then it was pretty much the same time when terragrunt started, so I started using it very early on. And now I see that you have kind of looked at this field one more time, because as I understand, you did not look into terragrunt before, right?
No, I didn't look at much at terragrunt or Terraform before. Like maybe 6 months ago, like you asked me some questions about this, I'd be like, I'm not very knowledgeable about that area, To be honest, like maybe ask Anton. now I know that you've written basically every single AWS module in the world. Not all of them, but wow, like pretty crazy stuff, and we could kind of cover some of that here. But I'm actually relatively new to the Terraform space, so that in some ways, right, that might be a disadvantage, but in another way, that actually might be very advantageous, because this is a fresh perspective usually. And I find this, like when I'm coding or doing anything, sometimes I'm just like, you know what? Maybe it's just time to walk away for today.
Yeah.
Maybe I should walk away, go for a walk, come back, wake up refreshed, and then I'll maybe be able to solve this problem, right? And that actually, like, even though maybe as, humans, we don't like to admit this, but sometimes like that's the best thing to do for yourself. Like, just walk away and like come back with some fresh eyes, and then all of a sudden things there's more clarity.
Yeah, that's pretty cool information to know. Like, I'm gonna to read a couple questions from people, because people are asking large amount of questions. So let me start from like from the oldest one, which I have already read. I will move myself to the side. So please share some information on how to use template rendering. I guess, well, I don't know how we can do this. Can you share your screen maybe?
Yeah, I can share my screen.
And,
I think it's shared already, but we're at the share within a share, so we have to kind of go
unshare.
We have to go meta, I guess. Oh, I have to unshare now? Let me try to unshare
well, no, I think I'm fine, so you can just share it.
So let's share. Hopefully you can see
yeah.
my desktop.
Yeah, we can see.
Cloud9. Okay, sweet. Oh, okay, cool. And then yeah, I can show essentially ERB rendering. And there's some trade-offs with everything. I found in the real world there are trade-offs. There's no like elixir. There's no cure-all for your problems usually. So yeah, I'll answer that ERB thing, and then I just kind of had a thought. You kind of mentioned that what you've seen with most people is they do like bash scripts to glue things together, right? Because that's what DevOps is, kind of like bash is the glue of DevOps, right? You just use this and you patch things together, kind of get it working, right?
Yep.
And you say you kind of said maybe I'm doing it wrong. I actually don't think you're doing it wrong. I think it's fine. I think that's how most people do it. But the context and perspective here is, most people, when they're solving a problem, they're on a job, right? They have a company, they work for the company, and then they have to solve that job for that specific company, right?
Mm-hmm.
And they have to do it with deadlines and timelines and everything. I have to do that too, right? However, the one difference between maybe me, BullOps, and maybe even like terragrunt, right? And people solving this problem with their bash scripts and all the glue is they have to solve it for one company, right?
Mm-hmm.
We have to repeatedly solve this problem over and over and over, right? And we have to solve it for multiple companies. So it's just very natural for somebody who's in consultancy company situation to kind of more abstract that out, right? Yeah. So that's why I'm like, do I really want to copy the same bash, script, shell scripts everywhere here? And I do that too. Everybody does that, like everybody says copy and paste is evil, but sometimes you copy and paste, right? So that's why usually it does start off for me. To be honest, it starts off with a bash script for me too. Most of the things I start off is it's a bash script. That's all I need. And then I start abstracting out, and then I extract out the concrete parts, because I'm not like most people, or I guess some people, like maybe professors. They're really good at starting off with the abstract concept and then going to concrete kind of implementation. My brain hasn't kind of worked that way. My brain is like, I need concrete use cases, and I start from there. Then I abstract out to the patterns. So that's why you kind of see what you see. But anyway, so to answer the ERB question, you see my screen, right?
Yep.
So I'll do a quick demo, and then in there I'll basically hopefully answer this ERB question. But anyway, so I'm going to go Terraspace new project infra examples, and that generates that project. So this is essentially what you already showed. I was keeping up in and out there earlier when you were talking on the YouTube stream. But you see this on the left-hand side here. What it did was it created basically all these folder structures, right? So it basically created a starter project with these files. And what I'm kind of go do now is I'm going to go kind of show how ERB templating kind of works, right? So, and you do a good job of explaining it. Essentially, these files in here, like the app modules, stack modules, and the config Terraform, these are the kind of this and this gets combined together. And then that basically builds a Terraform project. And then at that point, after that, it's pure Terraform. It's actually not Terraspace, it's just pure Terraform, right? Terraspace does some extra, helping logic, some convenience things like automatically creating the S3 bucket and all those things, right? And possibly running hooks and all those things. But after generating the project and compiling this project down, essentially, or materializing the project, however you want to call it, then you have pure Terraform, okay? And in here, you basically could do anything. You could do anything with ERB. So the templating language, I didn't invent my own templating language. Nope, I just used whatever was available in this case, the Ruby ecosystem. So this will actually maybe explain it a little bit. You go to here, docs, config, vars, how about intro, how Terraform works. ERB templating, right? So HCL ERB templating. So at the end of the day, you're going to be working with HCL files. This is just plain old HCL, right? But if you wanted to, you could use ERB templating. And basically, it says it right here. Basically, a very minor enhancement that Terraspace does is it processes each of the TF files right here within these folders with ERB. So ERB is just like a template language that looks something like this, time.now, okay? And I'll just do it with a comment. And then what I'm going to do is I'm going to go cd into the infra, Terraspace build. And then what you're going to see is it generates this file right here. And you kind of showed off the command earlier, demo, right? So there's a demo, and the path is right here, right? So you can actually, I'm not going to seed into it, but I'm a cat. Basically, oh, did I save this? Oh, it looks like this dot wasn't saved. So I got to save that again, and let's try rebuilding. So I'm going to rebuild there, okay? And then you're going to, maybe, I'm going to cat this guy now. So I'm going to cat, and this was what? This was the stack. So I'm going to go ahead and cat the stack, okay? And this was main.tf. See this timestamp that was added with ERB right here. So in a way, you can actually, because ERB is actually just plain old Ruby, with the view part, you can actually use any programming construct now, right? Like, even though the docs don't really emphasize that you got the full power of a programming language behind the scenes, because I actually think, for the most part, because most people are going to be used to HCL, you should generally stick to HCL, I think, particularly in modules. Maybe in stacks, use some HCL there, and then maybe in TFR files, you can use, also ERB and the full programming language power of a full programming language. So you can do things like normal loops, you know. I just do this. Like,
yeah, it's pretty cool. It's pretty cool to see possibility to extend functionality which can be naturally implemented inside of Terraform using ERB, or I was using Jinja for that many times.
Yeah, Python, Jinja.
Yeah,
and the Go templating language, right?
Yeah, and the point is that Terraform does not have this feature, but I need to do something about it. So the most like recommended way, at least recommended by me, is to use JSON.NET. So then you can generate JSON templates from the JSON.NET, so JSON file from JSON.NET templates, and once you familiarize yourself with language, it's quite powerful. Here you do similar things. It's pretty cool.
Yeah, 100%. And JSON.NET, I saw people doing that too with Terraform, but also in Kubernetes were a lot with JSON.NET. And for some reason, that seemed to have taken off also. I thought it just didn't fit right for my brain. Just maybe it's just JavaScript. I feel like it's a little bit too loose of language. I mean, because for what's worth, Ruby is actually a dynamic language too, it's an interpreted language.
Yeah.
But I think Ruby, I would say it's dynamic. JavaScript, I would say is loose, right? So loosely typed versus dynamically typed, right? And loosely typed is like, loosely typed means like stuff like this works, right? Like 1 plus 1, right? Oh, that's going to equal 11 string, right? That's like loosely typed, right? So I'm just like, a little bit too loose for me, right? But dynamic, I feel like gives you the right amount of glue to build things like this.
Yeah, but the main point of using JSON.NET is that Terraform natively accepts JSON. So
yes, it can. So there's a part here that I don't emphasize too much, but actually Terraspace can do this also. I just don't spend a lot of time on it yet because I think the HCL people are more used to HCL, and I want to get better at HCL myself. But you could actually write it in a Ruby DSL that then generates .json files, right? Because you're right, Terraform is actually cool in that you could write this, higher level language HCL, but you can also write in the JSON files, right?
Yeah, right.
So that's actually supported right now. Yeah,
that's pretty cool. Cool way. I think this kind of project would be very much in use and needed and asked before Terraform 0.12 or 13. So when there were no for each and people were struggling to figure out how to invoke the same stuff multiple times, and JSON.NET or Jinja or any other tooling was the only way to do this. But
you see that's where you have a lot of experience here, because you mentioned the specific numbers, right? Like 0.13, I believe that's when for each came out, right? So that's why you're like, oh, this would have been really grateful, right? And that's why people, I think, maybe use more terragrunt, because for each was our thing. It's for years, right? So that's Terraform is finally kind of catching up there, which I think a lot of people hopefully appreciate. I appreciate. I'm like, finally a for each.
Well, but there are still a lot of limitations, so take it easy. Okay, cool. Cool. Let's look into another question, because this question is pretty long. Can you give a hint how to control stage in production deploy based on Git flow? For example, use tags, branch, or maybe something else. Maybe you can advise good blog about that.
Yeah, 100%. So this is the problem that's always asked. How can I use the same infrastructure code to deploy and create a development version and a production version of my environments, right? And then it's the same thing that actually is asked in the application land too, where I want a development version or a stage version of my application deployed, and then I want a production version of my application deployed. But anyway, so the way you kind of do that with Terraspace is it's a concept that I actually took from Lono, and then also in UFO and these other kind of tools. It's called layering. Basically, layering works like this. You use the same infrastructure code, but then you build a different permutation of the Terraform projects. So you materialize a different Terraform project with a different TSENV. So, but in this case, the code is exactly the same, but you're going to be able to use different TFR files, right? So what layering does, and this is kind of the simple example of layering and an introduction to it, is you could basically say, put all my base or common variables, you know, and this is a concept, again, borrowed from not just my tools, but a lot of other tools, right? Like Salt, like Chef, they all have this concept of environment, and then there's a common kind of layer, like that's in configuration land. But anyways, it's the same concept. It's nothing new. It's just I'm putting together, I'm integrating it. So base is where you put your common TFR files. Let's say you want all the same, I don't know, instance type, right? And then dev and prod is another TFR files that gets layered like a pancake. So what you could do is, like, by default, the environment is dev. So it's going to merge base and dev together. And that produces basically the TFR file that gets used. And then for another environment, you would actually just go prod with the same code with different variables. So it's, I think, you know, obviously my opinion here, because I created it, right? But I think this is very dry, because you can actually just have your common variables here, and then only the delta, only the difference in environment-specific TFR files, because they get merged and layered. And the way it actually works for, you know, because I think a lot of the people who kind of follow you are actually pretty well versed in Terraform and all that. The way it actually works in the details is it actually just generates auto TFR files. So you see? So these auto TFR files, if they exist in that current folder, which is where we're running the Terraform apply command in, these are automatically merged. So I don't actually do any gluing logic here. I'm using just leveraging Terraform. And I'm like, oh, that's great. You know, that's awesome. I don't have to do more work, right? So this is kind of how it works. You will use the exact same code with a different environment here to essentially create a different permutation or environment of your infrastructure. Hopefully that answers that question. And there's a lot more of layering that I can get into, but it's kind of up to you, Anton. I don't know if that's worth it.
Yeah, no, I think it's a very good explanation. And the thing which I like, there are two things which I really like in your like last 3-minute speech, is that first of all, you don't like to do something what Terraform already does. So that's why you rely on internals very heavily. And that's, like, to my experience, this is really important, that your tool is not trying to be very smart in all of this, and you don't try to like predict what people mean, or maybe implement some specifics. If you do this and then it's just impossible to stay on top of Terraform, because Terraform is still developing like crazy. So one day they will get rid of some features, and well, hopefully, which is not going to happen in the near future, but still. But at least when I see something like this, it reminds me configurations which I saw people writing for terragrunt, where you can include optional and required configuration files. And you provide usually like from 1 to 20 paths, and then it will include the first one which is which it finds, or something like that. Well, you can do this, but in most cases we have to write code which is easy to work and easy to understand and easy to operate. I mean, you don't have to impress people that, hey, look at me, I can do these things which nobody understands. Because I mean, if we need to have this kind of competitions, let's do this. It's pretty fun too. But in general, we have to be focusing on something what is easy to operate, and generating these base files with auto extension is good point to my mind. But what about dynamic values inside of TF-vars? What about something what is not known in runtime? I guess it is inside of Dynamics folder.
Mm-hmm. So something that's not known to runtime, like say like the outputs from another stack, right?
Yeah.
Or basically a dependent stack that needs to be applied first before you could.
Yeah.
So this is the question. Of course, the first question you asked me, like when you hit me up like a month ago or 2 months ago, you're like, Tung, this is the first question. I was like, okay, man, that's hard. So let me sleep on it and think about it. So I went for lots of walks. And then eventually I was like, okay, I think this is the way it should fit. And this is actually what I was intending to do for another tool, actually. But I just never kind of got to it. And then I was like, okay, this is kind of the right time to do it. So then I implemented kind of a little more dynamic control. Okay. So first, to answer that question, like what if you want to use values from something that's lazy, that happens at runtime? I think that's where you use runtime, right? Mm-hmm. So first, just generally, see these TF-var files that I just showed you with layering? You could use layering, but the TF-var files, that's just my daughters running around making a tornado sound out there. Anyway, so here, you can actually use ERB here too. So you could use like dynamic control here too. ERB now gives you access again to programming language, right? So you have full control to like, and I'm gonna add a couple more concepts soon. I've just been kind of working on different branches to basically allow you guys to add your own method. So basically custom user-defined helper methods. But anyway, you can use ERB here, okay? However, there's some built-in ERB helper methods that are extremely useful called output, okay? So this output basically says, grab me the stack name called VPC, grab that output key here with VPC ID, and then assign it to here. But that's actually lazy. That happens at runtime because VPC is not going to be defined yet, right? So this is actually what the graph commands and Terraspace all commands kind of leverage. When you are calling this output method, it actually, what happens is Terraspace actually registers the dependent stacks internally. And then it uses that registration information to build up the dependency graph. And then when it comes time to apply this specific stack, which happens to be a demo stack here, that's when it's going to, at runtime or lazily, pull in the state file information and then grab the output. So that's how you can kind of grab information lazily between stacks, right? Because if you are grabbing information within, let's say, a Terraform, we're talking about pure Terraform now, pure Terraform module, well, you just grab it, right? Because it's just leverage Terraform. Terraform already supports that. And as of 0.13, at some point, depends on became a thing, and you can do depends on between modules. And I know you mentioned there's like some limitations that I don't fully grasp yet, but there are some limitations with that too. But when you're kind of building infrastructure and you're modularizing your things or organizing your code to like modular structures or modular stacks, like a VPC stack, an instance stack, right? A database stack. When you're doing that, you're not really gonna, you can either do like, you have kind of two options. You could basically put everything into one big Terraform God module that basically handles everything, right? Yep. Everything is coupled, but then you get for free orchestration from Terraform, because Terraform can handle depends on everything. But that's not what they recommend. They recommend you doing a separate state files in separate, essentially stacks or separate Terraform projects or separate Terraform Cloud workspaces, right?
Don't tell workspaces. Workspaces.
Exactly.
It's
and
forbidden.
So when you do it that way, you lose orchestration. So then what basically Terraspace does is it essentially helps you with that part that's missing from the tooling, which happens to be dependency resolution and then orchestrating this. So one part I want to show with this real quickly is, you see this whole output thing? you go dependency graphs and you go to TF vars, complex types. Here's the really interesting thing I found, and I just kind of found this kind of by looking at. So this is just another documentation page showing that you can use output to wire up a dependent stack to this stack right here. And saying, hey, simple types, you just go simple types as a string. That's just, by simple type I mean like strings, booleans, and like in number. But complex types, let's say like a list or map, those are more complex type. So you actually use the same code. Because what actually happens internally is a two JSON happens. So basically a JSON dump, or this gets converted to JSON. And guess what? JSON is actually understood by Terraform. So I was like, oh, that's cool. So that actually just works. It's like, here's an example with a list of string. See, list string. Here's an example of map string. And it just works. Now, what happens if, let's say you go, well, my stack downstream doesn't take this input format. This sucks. I need to kind of convert it, right? So it's true. You will have to convert it by using local variable and then using native HCL to convert it. However, there's actually another option too. You could actually use a toRuby method here. And then actually, and I found the Ruby collection methods a little bit easier to use. I'm just maybe more used to Ruby. But then you actually go to Ruby and then last A to JSON back here. So you have access to the full power of the filtering and selection methods from the Ruby programming language also. Or you could use locals here too. So it's kind of really up to you. It's kind of, Terraspace says, here are some kind of batteries included, conventions, some structure. So because I think that's the hardest part. Like literally when I was like starting to learn Terraform, like the first thing I saw was like project structure. There's like a million blog posts about like everybody's own opinion about their project structure. So I was like, okay, well, we'll just basically define something, but allow it to be configurable. If that makes sense. Anyway.
Yeah, I think one interesting point which you can do here is that once you set this as a variable, you can also use Terraform functions to convert between types the way you want. So let's say if you don't need all subnets, but you need, let's say, first subnet, then you can use element function inside of Terraform and get first element. The problem is that you cannot use functions inside of TF-vars files, and that's why you need to use something earlier than Terraform TF-vars, which is Ruby in this case.
Yeah, you nailed it. Yeah, that's exactly why I exposed this Ruby helper too, because sometimes you don't have access to maybe modifying that module, right?
Yeah.
I would say that most of the stuff that you should do though, you should probably try to abstract that business logic to the stack. So stack is just a term I made up, but I didn't make it up. Everybody else uses that term also. I think Pulumi uses the term stack also. I think terragrunt uses stack also. CloudFormation uses stack also. So stack is just another term.
Pulumi uses stack because Paul Stack works there. Hello, Paul, if you watch this as well. Okay.
Paul Stack?
Paul Stack is his name. His last name is Stack. Yeah. Okay. So well, there are more questions from people. Yeah, I think it's pretty cool. So I'm kind of excited with more questions from people. So keep it going, guys. So the next question is the app modules folder used when you build your modules from scratch, or it has some functionality when you create modules calling public git modules? So literally, does it run Terraform init?
Okay, so two questions there. One was the modules, when they're built, is it kind of being built from scratch? And the other one is, does it run Terraform init? I believe those are the questions.
Yep.
So yes, the modules get built essentially from scratch here because essentially, see this folder right here, app module stack, that gets mirrored. If you kind of go in like Terraspace catch, not that, okay, and then here. So look at what I just did. I just typed tree, in the cache folder that got materialized, and then you can see this is actually mirrored, right? So if your folders are kind of here, yeah, all just does a mirror. It mirrors over, and then here's the funny thing: this is using ... up, and it's kind of 2 levels up, then goes to modules, then go example. So like from the way you mentally think about this model is like, oh, that makes sense. It's just like where it is here. However, this is where it can get yeah, when I was explaining this to actually my buddy, he was like, that's a little bit confusing. So this next part might be a little bit confusing, but let me try to explain. Okay, so hopefully I answered that first question. Oh, okay, let me answer the init question first, and then I'll explain the little bit more kind of sophisticated way in which Terraspace can materialize this project. Okay, but init, yes, init gets run, okay, init gets run, but it gets auto init. So I introduced a concept called auto init. Let's see, under config here, under reference. And by the way, you know, when earlier you kind of said, let me answer init first, and I'll roll back my questions. Okay, sorry, my mind's kind of trying to answer. I'm juggling a couple. Okay, so init, basically, let's see, init. Right here, init mode. So there's 3 different modes for init, and it's configurable. So a lot of what you see is actually configurable. Batteries are included, but you can kind of replace and customize and have full, like a lot of control over the internals actually Terraspace, right? So what happens is when you were actually doing your demo earlier, you're like, let me find where the init log is, and you couldn't find it. Because, and you're like, let me scroll up a little higher so I can find it, right? And they're like, oh man, my history's kind of all the way up there now, so I'll just move on. Because init only runs when it needs to, right? It's auto init, and that's the default mode. But you can change it to always if you want. We can change it to never, okay? So whenever you call Terraspace up, so far, I believe the only thing I'm showing you guys is the Terraspace build. But let's say, I only show you Terraspace build. I'll run it again, but you don't have to kind of run that. I'm gonna actually clean up the cache completely, okay? I'm gonna go clean all, and I'm just gonna do it with Y to clean up everything. Otherwise, it kind of prompts you. So I'm just cleaning up all the the cache logs, the logs, and everything, right? Or you get anyway. So, but I'm gonna run a Terraspace all up now, and what that does is it does the same thing that I did manually, which is Terraspace build, and it tells you what it's doing while I was doing it. Then it does the Terraform init, and the reason why I clear my cache is so I can show you that the init was happening. See, the init's happening because I cleared out the cache, so it needed to init. Okay. So yes, init automatically gets called, but it doesn't all get called all the time because init, there's some penalty involved with that, right? It's a little slow sometimes. So watch me run again. It's gonna actually look. I don't see the init call. What's up with that? And Terraspace tries to tell you what it's doing. See, and here's kind of it's telling you that it's gonna run Terraspace plan, and it runs it. So it tells you the commands that it runs to. So it tries to be very transparent there. But here, init ran here in the first time. The second time it didn't because it gets auto init. And then kind of what happens is if there's like some kind of code you change that requires reinitialization, then Terraspace is going to actually do what you would normally do as a human being, which is run Terraform init, right? So it automatically is going to run Terraform init when it needs to, when it detects that basically it was an init error. And then it's going to then proceed to run Terraform apply and kind of move on. And then just now that I'm on here, look at this. This was kind of interesting. When I was messing around with Terraform Cloud, I noticed that Terraform Cloud always provides you with a plan. That's just how it works, right? So I really kind of like that because when you do like Terraform apply auto proof, like right here, it doesn't actually give you the plan. So let's say if you were like, you ran it, you walk away for coffee, then you come back, you're like, what just happened? Oh no, I ran I ran auto proof. Now I don't know what happened, right? So a convenience that Terraspace adds is it always does a plan before apply with the -y option. So then in the logs, you see it. You see the information because I'm like, I come back, I'm like, I want to know what changed because, a lot of people tell you, don't ever run auto approve, in real world, in use case. Don't ever do it, but we all do it, right? So this is like another kind of way to kind of know what happened kind of afterwards. Yeah, so man. I think I answered, hopefully, those 2 questions. And I said there was another thing I wanted to talk about real quickly about this module that gets built. Or generated or materialized, whatever you want to say, right? This module, yes, it gets kind of built from scratch, but it doesn't have to be built from scratch. So the other thing I want to talk about is Terrafile. So this thing basically is not a new concept. I'm not building anything new. This concept already exists. There's like a bunch of different Terrafile implementations, right? This is basically implementation written with essentially like a DSL. I like what you said about Ruby programmers. They just naturally write DSLs. I guess that's true. But anyway, so what you can kind of do here is you actually just specify the module you want. And if you don't have a version, then what it does, it locks that version and it snapshots the version by generating a Terrafile lock file. Okay, so basically you could go Terraspace bundle. And then what's going to happen is this file is going to be created now, Terrafile lock. And there. And then basically what it did was it did a lot of automation for you. It downloaded the latest version from master. and then snapshot that, and then you commit this to version control, and other people on your team will use it. They use the exact same version. And the kind of neat thing about this is you can use any module in the open source community, or let's say you have your company has private repos and stuff, then you use your own private repos too. But a lot of modules I found were all yours. And so I was like, dude, this guy's a machine. So I actually have a lot of demos actually using your modules and stuff, and I can show you that maybe in a later demo. But I think I hopefully have answered most of those questions. And the Terrafile in the demo, I'll explain a little bit more maybe thoroughly if we have time and everything, because it works a little bit even differently than what I kind of just explained. But I just want to give at least an intro to it.
Yeah, I think it's a really good point, and I'm sure that many people who use Terraform for some time, they discovered that, okay, Terraform tell us that we can control versions of providers and Terraform itself, and there are pretty good established principles already. But when it comes to versioning of modules itself, well, it's wild west. You can do whatever you want. I don't have to go far in history, but even this week, people who didn't pin versions became my beta testers.
Yeah.
So I released something what was not working for them, and they didn't pin version, and then they say, oh, now our pipeline is not working as it was before. So I said, thank you very much, and next time please pin your version. And if there would be tool like Terrafile, and again, I think that there has to be feature built in inside of Terraform, and I'm quite sure that it will eventually be part of Terraform 0.15, because 0.14 has already a log file for Terraform provider versions, and 0.15 probably will have even more constraint, because hey, 1.0 has to be released next year, so there has to be some improvements to be able to lock versions for everything. So
yeah, and I'm looking forward to that improvement, because I agree this should be happening in Terraform itself, right? But I think Terraform, they see themselves more as like the foundational like layer, like they provide essentially the wood, right? They provide the language, and because it takes a lot of time and effort, I guess. They haven't provided, I feel like, enough tooling to kind of make the workflow experience kind of like more smooth. So when that happens, like just use the Terraform one. That's what we would do. But I wonder though, when they do provide it, like, because here's the way they implemented this, which is kind of like interesting to me. Like here, right, and this is why other people invented Terraspace or whatever, right? So what you would do is like you use like whatever github.org.repo, right?
Yep.
And then you won't lock it here, right? But then if you if you will lock it, you will lock it like here. You go 0.01, right?
Yep.
So here's the thing, and then when you run init, it essentially analyzes your Terraform code, all of your modules, right? And then from there, it's going to require all the dependencies, figure out all the versions, and download all the providers as well as modules. So it's doing that with init. But this approach I thought was like kind of interesting, because for what it's worth, I did the same approach with another tool, which I kind of regret. So I was like, oh, don't do it this way with Terraspace, okay? Yeah. Because the versioning is now embedded in your source code all over the place. Yeah. Right? It's not centralized. So it's like, now you have to do grep. You have to do the find. You have to do the search until you find all the places, then you have to update in multiple spots. And that's just kind of the nature of the beast of how it currently works.
Well, to make this simple, especially what I use during workshops, and if I'm talking to people who are familiar with with software development, and then they ask like, oh, Terraform is another type of tool and it does not actually do the same things as we get used with software development, then my best explanation is treat modules as libraries. Like literally, you probably have package.json file or Ruby or gem file already in your repository, or gem file lock in your repository, which already contain all of this information about your dependencies, versions, and so on. So the same has to be in centralized way in known location. So anyway, I think people will eventually start using more tools like Terrafile or Terrafile or whatever they're called now, because there are at least a couple years ago there were about 10 of them, which you can easily go on PP and Ruby Gems website and easily find anything you want. So yeah, that's definitely going to happen. Okay, we have a couple more questions. This one is a little bit long. We'll try to read it. Can one use Terraspace to simplify creation of stacks in linked AWS accounts from the management account of the organization? For example, via AWS provider assume role property. So I think what Sergey meant was, is it possible to manage infrastructure in multiple AWS accounts?
Yeah, it is. So this is going back to layering now, right? So I'm going to now talk about the maybe more advanced layering, because I kind of mentioned layering earlier. I'm just showing you the link right here on basic layering, which is base, dev, and prod, right? Mm-hmm. So this is the idea, the concept. I think I did it more proper this time. And the other frameworks I wrote, layering is supported too, but because Terraspace or Terraform itself actually is so interesting because it supports multiple cloud providers, I took a different approach. So anyway, layering here, okay, basically layers base and dev or base and prod, depending on TSEMV. Full layering, which I'm about to show you now and reveal, right? Mm-hmm. Is actually a lot more powerful. This allows you to use the same infrastructure code, not just to create different environments like dev and prod, but actually deploy to multiple regions or multiple accounts and even multiple providers, right? All these layers are basically stacked on top of each other like a pancake. So when I showed this to some other coders and engineers, they were like, oh, it's like inheritance kind of. I guess that's one way to think about it, right? Basically, base, it's all common stuff. And what I did was, because there's so many layers here, I kind of started to organize this documentation. I just put these kind of layers together in group for the sake of conciseness, I say. So base and dev, they get merged here in the root folder, but then you can actually create a region folder here. Here's an example. And then basically you have base and dev in here too, and those kind of get pancake and stacked on top of each other. Or namespace, and namespace, the reason I'm using a generic term for namespace here is because there's multiple, Terraspace out of the box supports both Azure, Google, and AWS. So namespace in AWS is the account ID. In Azure is the subscription, and Google is the project. It's the same thing, and it's just different cloud providers, right? So what you can do if you want to deploy, let's say, here's an example of multiple regions. Now I'll show you how to do it with multiple accounts. Okay? So multiple regions, you would just say, a different region here, and guess what? A different project gets built, gets generated, gets materialized. Right? Because that's included into the Terraspace cache key, which is, again, also configurable. This is all configurable. And then what you can do is you actually say, hey, deploy to a different region, right? All the dev environments, or deploy to a different, region of all the prod environments. And then you could actually do the same thing in the account. Now, with the account, what I actually like to do is, at least in the projects that I've worked with, I set up a production account tied to the development environment. And I set up, I'm sorry, I just really mixed that. I set up a development AWS account to the TSV environment, dev environment. And then I set up a production AWS account, a segregated account for security purposes and just a nice guardrail to a TSEV prod. So then kind of what I would do with that is actually I would configure the environment to override. So you see how there's an environment to override here? You can actually go in here and you could configure the framework with this configure block here under config app, and then you can configure things like the logger and stuff. But you can actually configure let's say specific environmental variable overrides. I guess maybe I do it also here. Is that where the docs are? No, this is with our vars or I'm trying to figure out where can I have the docs for that boot hook. Oh, it's a hook. Duh. Okay, so there's a hook that happens very early on. With Terraspace that you can actually use to then run any kind of hook logic you want. And that's where I usually, I can't really find it right now, so I'm going to have to maybe look that up later. But what I'm saying is, what I would do is I would use a different layer that's specific to environment, but I wouldn't actually specify the kind of ID there. You could do it. You could do it with the environment variable, but I actually tie that to like a different AWS account, to different TSV, EMV, and then automatically have that AWS profile switch over as part of DMV. So they're always, so I don't accidentally deploy like development to production, and I don't deploy production to development. I don't want that to happen. So what I'll do is actually configure, the settings to say dev deploy to a separate account, prod deploy to a separate account. But yes, that's completely all doable, and it's done with essentially the power of layering, and and then you can make it a little bit this flow smoother with basically config hooks and stuff like that. Hopefully that makes sense.
Yeah, I think it makes sense, but the idea which Sergey was highlighting is that is it possible to use Terraform, let's say Terraform provider feature, to assume role in different accounts? So let's say, is it possible to configure Terraform or AWS provider to assume role depending on which environment you are managing?
Well, if you can do it in Terraform, then you should be able to do it in Terraspace, but I don't really know. What I do is I actually just go configure that provider. Then I use AWS profile to automatically switch. That's how I kind of do it myself personally. But yeah, if you're kind of having a whole, like, if you're using actually HCL to switch providers and stuff like that, then whatever you can do with HCL, you should be able to do also.
And that's actually very much related with a comment which here is it. Sebastian wrote, "Love how transparent Terraspace is," because as you said that yes, there are a few concepts which you add on top of existing Terraform, but most of these concepts are not limiting you from what you can do with just HCL. I mean, you can still write whatever you want in Terraform configs, and you can use 100% of features. Actually, when you're explaining this now, I see few things and few different like extra or additions comparing to what I cannot do with terragrunt. For example, in terragrunt, it's not possible to use so terragrunt gives you few possibilities to specify dependencies, and terragrunt adds few functions itself. So if you start using terragrunt, it will be harder for you to go away from that, which is not a problem in most cases because people are not taking this so often. I mean, you don't change between Terraform and terragrunt daily. But this is just one thing which I think is quite interesting.
Yeah, I think there's a philosophy thing too, a philosophical thing. So like 3 years ago when I started like BullOps and I started thinking about how I'm going to build these tools, it just, I took what thoughts in my mind. I was like, philosophically, how do I like to build tools and how I like tools to work is it's usually like a light layer. And then it tells you transparently what it's doing. So it's printing out the commands, right? Yeah. So philosophically, I wrote this blog article still somewhat applies because it's just saying that, look, a lot of people just like are kind of obsessed with that cloud agnosticism, which is, I think it's really hard to achieve. But then they don't really consider that tools change too. So whatever tool you provide, you kind of get stuck with, right? Unless that tool kind of says, hey, we're just providing a lightweight layer. And then guess what? You still know what's going on underneath. And some people think that's called leaky abstraction, but I think in some ways leaky abstractions are okay because then you know what's going on, right? So that's what I try to do with most of the tools. So it's just like that article still I think applies generally. I say generally still applies because in the article I emphasize light tools, but I will say that this is not necessarily light tools. The tools get more complicated because the requirements get more complicated, right? But overall though, it's still just bleeding through and saying, hey, Terraform already does this. Why are we going to spend time not doing something Terraform already does? And then Terraform, and if Terraform is going to release something new, then we're probably not going to work on it, right? But then it depends because sometimes, they have to prioritize things, and that's totally understandable. Sometimes they take years, right? So then we will have to kind of do it if we need it. Yeah, that's. I think that's the main reason why there are so many tools and so many different solutions. Some of these solutions are quite similar.
is because people have two options: whether sit and wait when someone else fixes this for them, or they start working on it themselves, like you do in this case with Terraspace. Which brings me to the next question. So the next question by Maxim is, why Terraspace suggests git ignore.terraspace cache? Like it should be more or less stable. Why not track changes on it, even it kind of orchestrated or generated? Even
so is it why are we ignoring this file?
Yeah, I think I think that's the main question. Yeah.
Sure. So sometimes actually I recommend not ignoring this file for the specific case of Terraform Cloud or Terraform Enterprise. But if you're just running Terraform and you have full CLI control of it, like here, then yeah, I think this should be ignored because these kind of like, this is generated like, files. So you can commit them if you want so you can see them. But what you're going to do is you're not going to change the cache files, right? Yeah. Those are generated. So usually like artifacts are usually ignored, I think. So you would change the original source files, and then the generated files you would usually get ignored, but I guess you commit them if you want. Now I said in Terraform Cloud, right? So Terraform Cloud supported out of the box. Where is it? Cloud here, I guess. So Terraform Cloud, it just allows you to run your Terraform scripts remotely, right? In a consistent virtual machine is kind of what they say in their docs. But Terraform Cloud has two different workflows, or three in their docs. There's a CLI workflow, a VCS workflow, and an API workflow. But really, the API workflow is handled already by the CLI workflow because they provide the tooling. We're not building anything that we don't need to here. So the CLI-driven workflow works is just like what you see here when I ran like Terraspace, up demo, okay? So that's the CLI workflow. But the VCS workflow works a little differently. VCS workflow is essentially version control is the source of truth. That's what their docs say, okay? So that means you have to commit the code, right? Now, you can't really commit, just by the nature of the way Terraform Cloud is built. You have to commit Terraform files. You can't really commit like Terraspace clouds because those are source code files that then builds a project, right? Yep. So in order to run Terraform Cloud or Terraform Enterprise VCS driven workflow, bunch of words there, right? You have to actually not ignore this folder and commit those source code files. And I know people, it's interesting because that question is like, you should commit those files, but most people will say you should commit those files. Yeah. And now I'm saying for this, you're supposed to commit the files because you have to, because that's the only way to run it. And then I think some purists are going to say, oh, you shouldn't commit those artifacts. That's horrible, blah, 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 right? Well, that's kind of the only way you can run it on this particular platform. And I actually don't think it's that bad because that's what you're going to see in the diff. Whenever you're using Terraform Cloud or Terraform Enterprise, you're going to see the diff, and you're going to be able to apply that diff. Yep. And this was actually built specifically for this use case. The way, after I re-architected it from 0.2 to 0.3, the way things were built specifically for Terraform Cloud because of this version control workflow, right? But I want to emphasize here that it's not just, okay, Terraform will, or Terraspace will, you commit these files, then you have to go there to Terraform Cloud, like the dashboard, and manually wire things up, manually set up your environmental variables, manually set the builder, or the working directory, is I think that's what the settings called, right? You don't do any of that manually, actually. It's all automated. Terraspace automates as much as this as possible. What I kind of mean by that is, you see, when you set up workspace names and stuff like this, you actually set up like a remote backend here with the expansion pattern again the same. And guess what? The cloud vars can actually, you can write the JSON here, and those will actually get synced over. It's everything in Terraspace is very one-directional. One-directional, and I learned this from actually a JavaScript framework called React.js. Like, they had a concept of like very one-directional, and that helped them solve some of their bugs on Facebook and all that kind of stuff. I think Facebook was So anyway, so it's very one-directional versus kind of like, having multiple things happening in multiple directions. It's just, here's your source files, and you're going to sync it this one direction. That makes it very, very clear. So these vars JSON file here, these are variables that are going to be in one direction synced to Terraform Cloud on all your workspaces, because the issue with Terraform Cloud is they recommend you create all these workspaces, but then you have to manually go do that, or you write a bash script to do that, or you write some type of script to sync that. Well, Terraspace does that. Terraspace will basically create the var files, whether or not they're secret var files, sensitive, I guess, or non-sensitive. They will sync it over, or whether or not they're environmental variable files or regular Terraform variables in the TF Cloud dashboard. It will sync that over. It will also automatically use the API to set the working directory, so it switches. So you're not gonna go. I just want to be clear. You're not gonna kind of go. Here's Terraspace info demo path. See this path right here? You're not gonna go and manually configure this.
Yeah.
It does it for you, right? So like Terraspace Cloud sync help here, right? So this sync command, what it does for Terraform Cloud, and I guess it is applicable for people who are using Terraform Cloud. But if not, I guess they're not gonna care about it as much. But what it's gonna tell you what it's gonna do. It's gonna say, hey, you want to sync all the projects? It's gonna take this stack and then it's gonna create this workspace. And it's gonna sync all the variables over. It's gonna sync the working directory and set it to the one that I just basically listed out with this command here. So you don't kind of do it manually, right? And then when you do apply, it essentially kind of makes that CLI call over. Just use the CLI. So it tries to automate as much as possible. And by the way, the sync command, you could run it separately. And I only did this because of a specific use case. If you're like TFE admin doesn't want to give you permissions to create your workspaces because he wants administration access and he wants to, like, for security purposes give you a guardrail, then he's not going to let you create the workspaces, right? So what you can do is you just tell him, hey, can you run this to create all my workspaces ahead of time for me, right? But normally, if you have admin permission or permission to create the workspace, then you could actually just run Terraspace up, and then the workspace will automatically be created by Terraspace also. It just depends if you have admin permission or not. Okay. So anyway, I went on a tangent there with Terraspace to answer this question. This should be ignored. I think generally it's just my opinion. You could not ignore it by just deleting this, I guess.
Well, I think again, this is a third point which we have during today's conversation when we can easily compare this one with software development principles. Like, if you would write code, would you commit your binary? Well, sometimes yes, sometimes not. Would you commit your minified files in JSON or your TypeScript and JavaScript? Well, sometimes yes, because there is no way to compile from TypeScript into JavaScript, but sometimes not. I think at least for me, this was a little bit confusing, is that there is one Terraspace cache folder, but there can be a lot of input variables. For example, I can set ts underscore I think env, or what was the name of it, prod dev, and then it will simply recreate only one cache folder, which is a little bit confusing because to my mind there has to be many cache folders depending on which input parameters you provide.
So it actually creates all the cache folders. Okay, so this actually goes to the Terraspace all command, okay? So the Terraspace all command, what it does is it builds a dependency graph and then it executes things in parallel as much as possible, right? So imagine multiple processes on your system, right, on your computer, writing files at the same time. That's not going to work, right? So this is where I had to re-architect Terraspace to generate all the files at once. And this also was when I re-architected it so it worked for Terraform Cloud, because it has to pre-build everything. It has to. It just, so it actually, when you run Terraspace build, it's optional to specify a stack name, because it only needs one stack name in order to have enough, I guess, information to then build all the stacks and all the modules, because it does it in one go. It does it in one go at the beginning, all up front. So the demo shows you only one stack, but if you have more stacks, you're going to see, if you do a tree command in your cache folder, you see all the stacks being built. They all actually get built. That has to work that way in order for parallelization to work, essentially.
I see, yeah. And one observation which I see here is that I didn't know about this integration and Terraform Cloud sync from Terraspace. What you can utilize as well is that you can utilize Terraform Cloud provider or Terraform Enterprise provider, TFE, to manage all of these things like variables, policies, run trigger, user permissions, and a bunch of other things. So instead of relying on API and creating these files physically, you can just generate HCL file for the user. Again, this file, I don't know. I mean, yes, this file actually can be committed as well as code. I mean, there is a TFE provider, which is official provider by HashiCorp to manage both SaaS version and enterprise version. So that's,
yeah, and that's all configurable. So you could use the you could use the enterprise version. So this is just showing here in the docs. It shows TF Cloud. But if you're on enterprise, right, you have an on-prem install or whatever on your data center, then you could just change this to the org and everything.
Yeah, I think
I think
pretty cool.
Oh, sorry, go ahead.
No, go ahead.
Oh yeah, I think I have somewhere. I don't know where here, but oh yeah, I think it was the login one. I specify. So most of this documentation is written for TFC, but TFE is TFC. It's just a different variation of it, designed to be installed in your own data center, right?
Yeah.
And I noticed that when you call login, it defaults to TF Cloud. But then when you log in for TFE, you have to specify the host name that you set up, right? Whoever your HashiCorp representative is, they help you set up, and then you just go log in with the host name, and then you can configure it. Or, and that's how you authenticate against TFE. So the docs basically show TFE and TFC, and then it calls out when it's different for TFE.
Right. Yeah, that's. I mean, I think you develop a little bit too much, to be honest. For how many users you have?
Now look, this is brand new. This thing exists. Remember, this thing exists like a couple months ago.
Yeah, exactly. So everyone who is watching this right now, you just probably cannot imagine how much work is it. But yeah, few months of work and here you are.
It's a few months of work because I have 10 years of previous experience, right?
Yeah, exactly.
My friend says because he saw this happen and he was like,
yeah,
how is this possible? And then he was like, I think you've internalized the patterns. I was like, oh, maybe that's what's going on, right?
Yeah.
But, I mean, I do work a lot, so I mean, it's
and that's really the cool part, is that once you build one tool and then you can easily, let's say, abandon it because your knowledge is already stuck in your head. You don't have to make continuation for that tool or try to come up with it. You just kind of start new tool where you copy a large amount of your ideas and your solutions. And now, okay, so this, let's say this season Terraform is popular. Cool, let's make Terraform framework. So I think it's really a right approach. And there are more tools which people need. So I really like to see when people like you just come up with any idea and they didn't find any solution for the problem and they just start writing it and here you are.
Yeah, remember, I didn't go off trying to, I'm going to create a tool, right?
Exactly.
Man, it can't be this painful. It can't be this bad. I was shocked.
Yeah.
I was like, no, this I have to do it this way. And I was like, I have to work in this client project. So I'm like, no, it's got to be less painful than this, right? So then you start and then you just kind of keep on building it.
Yeah, I think that's really the case. Cool. There is a comment from Max who says, Terraspace plus terragrunt, is it even possible? And is it worth it?
So you could use the modules that use the terragrunt, but it's not really possible because terragrunt has the terragrunt HCL file. So of course I studied that tool too, right? I studied a couple tools. I studied terragrunt. I studied Asteroid from
Astra.
Maybe?
Astra.
Oh yeah. And then there was so there's some tools out there. But when I look at the terragrunt HCL file, that's basically what would be converted to TFRs.
Yep.
Right? So that's the difference. They have that's one of the differences. There's a couple similarities too, like you said at the beginning here. But one of the difference is terragrunt introduces a terragrunt.html file, which I'm sure a lot of your viewers kind of know. But essentially it's a custom syntax on top of HCL, right? Because they have something that's pretty cool. They can actually hook into Go and all that. I think that's awesome. Yeah. But it does conflate the HCL syntax with terragrunt. So then it's kind of like Ruby and Rails, right? There's some Rails developers out there, and I don't think that's necessarily a bad thing because Rails has done such a great job, but they actually don't know as much of the difference between Ruby versus Rails, right? So some people might not know the difference between terragrunt HCL versus Terraform. because
right.
the syntax is kind of combined. So no, I don't think you can use terragrunt with Terraspace per se like that. I guess there's a way I could probably hack it. Maybe, I don't know. I haven't wrapped my head around that yet. But what you will have to do currently today is just take the HTML file and then inputs. Then you have to change that to TF-var files, right? And then those TF-var files, you use the helper method that shows you to wire, you know, the stacks together and build, like, you know, the dependency tree and all that kind of stuff, you know?
Yeah.
Like this stuff right here.
One more thing which I kind of forgot to mention is that that's really cool that you have possibility to have Terraspace cache folder, and then occasionally you may want to commit it to repository trigger build. There are a few very rough solutions which you can do with this approach. Like, this is just thinking loud, but imagine the situation that you want to run something like Python or Ruby or anything else inside of your Terraform Cloud instance, and you don't want to pay money for that. So I mean, you have to pay Terraform, what is it, Cloud runners. I think, I don't remember the name, but there is a way to run your own custom runners, which you can provision with your own tools. So
I did not know about that. That's crazy. That's interesting. So is there like a hook into Terraform Cloud where you can do anything you want?
Well, you just provide your Docker image, which contains Terraform and all other dependencies which you need. So you will have to...
That sounds like you could basically set it, basically Terraspace can be integrated even more tightly. All we have to do is build a Docker container with an entry point, and then that entry point is basically the thing that's going to get called before. So then we want to commit the artifacts, right?
Yeah, exactly.
Like you were explaining earlier, you explained perfectly. You're like, I know I'm not supposed to commit binaries to my GitHub repo, but sometimes it's the only way. I do it. We've all done it before.
Well,
you know?
but I have not finished. For this situation, you need to pay money. Now let's talk how to save money. So the case when you want to save money, but you want to use something what is not available. Well, I don't know if it's going to work, but again, I'm just speaking or thinking loud here. Is that you wrap your... so first of all, you commit first module which does only one thing. It will execute provisioner. And this provisioner will download the whole internet which you need, and then you run it locally. So you commit code which looks good. The only thing which will happen in there is curl to this URL, and then unzip this large archive and run it on that operation system or that container which you get allocated. So this way you can install something what is not available, but you really want to use it and you don't want to pay for that.
Oh, I see. Yeah, I didn't know about that. That's awesome. I'm gonna have to.
Well, I didn't. As I said, it was just my thought process and how to get job done, which I usually focus more than whether it is right way or bad way. I want to get job done and go to the next thing. Yeah. So that's one way, but it's a little bit rough, but it's definitely a cool way to go around different limitations. Okay, cool. So we have even more questions, which is pretty cool. Another question by... Right, Maxim is the guy who asked about gitignore and Terraspace cache folder. He also asked, seems dynamic vars need cache gitignored.
I would commit those actually, but it depends, right?
Yeah, in this regards, what about secrets? Like, let's say there are plenty of places where I can put secrets, and what's your ideas or what's your workarounds about that?
So there is no workaround for it currently today, but the idea is probably introduce helpers that are cloud specific that will pull the secret from SMS for AWS, right? Or for AWS Secrets Manager or Google Secret, right? I will kind of pull in there, so then you actually can commit the code, because then, and this is not a new idea because I've already written this in another tool that kind of does this dynamically. Now, however, from like a security, I guess, perspective, compliance perspective, the secrets is not going to be committed code, but it's still going to be in your state file, right? So it's not one of those things where it happens all server side and it's now in your state file. So then the only thing you really have to do in order to get the state files, you can't run it on your machine, right? That's how you get on the compliance side. You have to run it on a CI/CD build pipeline, or you have to run it in Terraform Cloud or Terraform Enterprise, right? Because it's passing through your machine, and then your state file has the secrets, right? Unless hopefully Terraform, comes up with some type of, I don't know, encoding or encryption. I mean, to kind of help you with that. So then at least you have to have a key to unlock it. But that's how I probably approach it. I probably say, hey, add a secret helper method here that's specific to AWS. Add a secret helper method here that's specific to Google, and so forth.
Right. Yeah. So that's so far this is the only approach which seems to be required in the near future, and I don't see any plans or any clear solutions or any aha moment from anyone who said like, oh, we now know how to do this. Because there are known issues, known limitations within Terraform itself, which it's just impossible to go around.
Yeah, it's an unresolved problem. It's one of those unresolved problems.
Yeah, exactly. Cool. We already almost 2 hours, which is pretty cool. We have a few more questions. So thanks a lot, everyone, for asking these questions. And I already kind of think that we will have to make another interview and another session with Tung, because this is getting way more popular than I personally at least anticipated, and I thought that there will be no people. But hey, come on, there are.
You have people watching your stream. It's my stream that has no views, right?
Well, no. Actually, talking about your channel, there is this comment by Maxim, who said that Tung, you have a very nice YouTube channel. I just subscribed.
Really? Yeah, I got an additional subscriber.
Yeah, so you will see your graph skyrocketing today.
Yeah, and when the baseline is low, pretty much anything skyrockets, right? It depends where the baseline starts. Thank you, Maxims.
And another guy, David Lozano, just wrote is that I see most of Tung's infrastructure as code YouTube videos are about CloudFormation. What did make him to start using Terraform, and what advantages over CloudFormation he has found in his journey?
Oh yeah, the CloudFormation versus Terraform question, sure. So the reason I do a lot of CloudFormation is because I do focus usually on AWS, right? And the AWS CloudFormation tool, the native orchestration tool, and for AWS is CloudFormation. So this makes sense. You just use CloudFormation. When you're doing AWS work and that's your sole focus, that's AWS work. Well, it didn't become my sole focus because the projects changed, kind of, right? So some of my client project, they require basically use of Terraform. So that's the reason why I started using Terraform a little more, right? And yeah, I do see pros and cons of both. This is going to be one of those questions where it's like, it depends, right? So there are some things where I think CloudForm is ahead of the, on AWS in terms of Terraform, because they own, the tool. They already know what they're about to release, so they're going to hopefully work in the providers. But there are some cases where Terraform's actually ahead, right? Yeah. And some providers, like Terraform, is kind of ahead. They work a little differently. CloudFormation is stateless. Terraform is stateful. There's some pros and advantages of both. Stateless just means you don't have to deal with the state. There's no conversation in CloudFormation about how you configure backend TF. Yep. You don't. AWS does it for you, so that's kind of nice. However, then AWS does it for you. You don't have control of it, right? Terraform, you have control with it. You can actually move the state around, adjust things if things don't match, and just generally the behavior is a little bit different. Terraform does a plan where it reconciles what's different out there on the physical cloud versus what's in your code before. CloudFormation, because it stores the state information, kind of blindly assumes that the resource is still in this state. So the behavior is actually pretty different. And depending on kind of your level of advancedness, you probably actually prefer to control the state file. Just depending on how deep in the weeds you are.
Yeah. But also CloudFormation clearly figured out that they don't want to lose this game. So they came up with significant amount of features like drift detection, for example, where you can actually see that, oh, some of my resources have changed. I personally feel that the feature is good, but implementation is not very natural. I mean, you have to do extra step in order to see what's wrong. In Terraform, it's quite natural. You just run apply, and it run plan for you. Which is...
So I completely agree with that, actually. So that's actually what Lono does. Lono runs a change set so you can see it, and it doesn't do the drift detection because, you know, that's a sync call that takes a while to kind of generate all that. But it actually does a diff, but it does a diff more than just the diff of what's called the change set in CloudFormation. It does a diff of actually the different generated YML, essentially, so the code too. And then it also does a diff of the parameters, or in CloudFormation they're called parameters, in Terraform they're called variables. But actually tells you the different variables you're kind of applying to. That all gets kind of aggregated and summarized in just a Terraform plan. So Terraform, I think you're right. I think the workflow of Terraform plan is actually much smoother, especially with, it's like there's no comparison if you compare the raw tooling there. But Lono, like I said, that framework makes it so it's a little bit up to par, but it's still not, I still think Terraform plan is actually provides a better preview.
Yeah. Cool. We have one more question, which I guess is the last one, which is not answered. So the question is, can Terraspace simplify creation of stacks in multiple environments in a single run? For example, create stacks in n regions in parallel.
So with the way kind of the docs lay out, it's not designed to do it that way. You have to actually call it twice. However, you could do whatever you want to do with Terraform, right? So if you want to have multiple regions, guess what you do? You wouldn't actually follow these conventions and these kind of defaults that Terraspace would set up. You actually shove it into, guess what, a bigger module. And then the bigger module will kind of handle that. So it kind of leaves it up to you, right? Because it's configurable, right? So look at these configuration settings, right? It has all these different settings where you configure. So what I'm saying is you could use layering, but you could opt not to use it too. There is no kind of, there's no like all command, I guess. Like even a higher level command all that will loop through both of the regions and then, or both accounts, and then kind of deploy both accounts like that. Don't know if that will be created, to be honest. Not sure. I'll have to sleep on that.
Yeah, that's pretty funny, is that there are so many different ways and different solutions which like how we can solve these problems. And while you was talking about this from Terraspace, I was thinking how I would do this in, let's say, other tools or in native Terraform. And again, there are infinite amount of ways how you can do this. But the first way which naturally comes to my mind when I hear something, when people say, hey, I want to do this, but across multiple things. Hey, we still have make files, we still have shell. If there are some things which Terraspace now cannot do for you, well, you write your own for each and you run Terraspace 20 times. You can
I think that might be the better approach. That's why I'm hesitant to say, hey, you know, is that something that it should handle? You know, but you know, I mean, if it doesn't handle, just shove it all. Don't use region, right? Use global or something.
Yeah,
right?
Yeah, exactly. So there are, I mean, this is just an example of solution. Again, I don't know the best solution myself right now, but in general, the tool takes responsibility for combining Terraform project for you and run it for you in multiple combinations. I guess if we think, let's say, for 5 minutes, all of us can come up with situation where, oh, sorry, but Terraspace, I cannot use Terraspace in my project because it doesn't support this and this natively. Well, that's the same with all tools. So
yeah, that might be a feature, right?
Exactly. It's by design to not let people do crazy things.
Too much rope, right?
Yes.
Yeah, it's something I struggle with because it's always a balance of trade-offs, right? There's no elixir in the real world usually. You're right.
And I have one of last question from myself, which is actually, what is your current plan about Terraspace versus Lono versus many other projects which you didn't talk about but I'm quite sure that people who watch this stream, they will go to your GitHub and learn about Jets and about a few other projects which you developed. So what's your plan? Like, are you going to abandon 10 years of work on Lono, or are you going to develop two things simultaneously? What's your plan?
Yeah, that's definitely something I struggle with. Software, if you don't update it or rewrite it yourself, somebody else can rewrite it. That's just how it works, right?
Yep.
And that's the software world. We live on kind of ground that always moves underneath our feet, right? So, you know, I actually would love to be able to take some of these concepts and eventually, like, basically upgrade some of those other tools to kind of, to basically improve them, right? So I want to take a lot of Terraspace concepts and put it into Lono, all that kind of stuff. But there's only 24 hours in a day.
Yep.
So it's about priority, right? So maybe I can answer in terms of priority. Right now, my priority for me is currently Terraspace, right? I want to get to the kind of the end of the finish line in terms of like features where I think it's like 80% of the way there, so that, you know, it's kind of stable. Like for what it's worth, Jets, it's kind of 80% of the way there. So people have been using it for a long time and it's fine. I do need to go back and kind of get Ruby 2.7 support kind of adopted there. Lono, I actually feel like I need to improve it a lot because I learned so much in doing Terraspace. There were so many things in Terraspace I did because of Lono. Because I was like, no, I took this shortcut here and I really regret that and I'm not going to do it this time with Terraspace. And it turns out sometimes, even though it's counterintuitive, when you don't take shortcuts and you do it the harder way, you save time. Because I notice now that there's just a lot less kind of technical depth with Terraspace than there is with Lono. So I don't have to change like 3 or 4 files because the copy and paste duplication I created, you know, the beast I created myself. I was like, oh man. So I'm like, oh, I'm going to have to do that, right? And Lono, I actually want, so I was at the cusp of finishing Lono bundle before I wrote Terraspace bundle, right? So a lot of that code is kind of finished there. I want to go back. But right now, I think with the business and everything, I'm basically be focused on Terraspace. That's kind of where it seems to be the direction things are heading on in terms of priority. I don't really want to say I want to give up on all those other tools yet, but yeah, if I don't do something about it, right, then yeah, eventually somebody else can rewrite it, and that's just the nature of the beast. Hopefully, you know, there's more people that maybe want to contribute, and like if they're interested, and then like, you know, then I'm more than happy to kind of review pull requests and kind of, you know, and consider them and all that. And I do that. I'm pretty rapid about that. But yeah, there's only 24 hours a day. I think my priority right now is probably Terraspace. Yeah,
right. Yeah, that's sounds like a great plan and great vision, at least from my point of view. But then, do you have any like not feedback, but any expectations or any help which you want from the community, or let's say, what are top 3 things which you want people to do? Literally. I mean, okay, subscribe to your YouTube channel, subscribe to your GitHub, follow you on Twitter. That's fine. This is like step 0. Next.
So that's step 0. Maybe star my project.
Okay,
that'd be cool. That's the easiest thing. But anyway, so I think the main thing is you already covered it. Like nobody really knows about Terraspace. You know, nobody knows what it does. Nobody knows what it's about. So use it, you know, share it with your friends and all that. I think that's important for the project to gain traction and actually, to be honest, just motivate me. There's comfort in numbers, right? So that would be nice. Then maybe QA, right? The more users you use it, and you know, the more users who are testing it. Like you said earlier, hey, I got some beta testers, right?
Yeah.
I appreciate that. And the reason I appreciate that is because most people don't like being in the position of being guinea pig, myself included. I usually like tools to be generally pretty stable before I start like messing around with them, right? But some people are okay with being guinea pigs and stuff like that. So, you know, just go test out. But for what it's worth, I would say that I do a decent amount, because I've written a lot of these different tools already, but I do a decent amount of QA. So whenever, before I do a big release, all 3 cloud providers are tested with real resources, Azure, Google, and AWS. And what basically happens is I run a pipeline. I literally run a pipeline that builds all 3 projects and then creates real resources, real physical resources, and then tears all down. I use actually the test framework to do that. So what I'm saying is you're gonna be, you could hopefully help by being like a guinea pig, but it's not gonna be that. It should not be that unstable. The baseline should be there, and that integration build should kind of over time get more and more hardened, right? And then just feedback generally, like if you have some questions and stuff, like be sensitive to everybody's time, right? But this but just go there and ask some questions, things about how you can improve it. Be kind, come from a good place, right? Just feedback is always appreciated, especially constructive. If you're just like not constructive, then maybe not as much appreciated, right? Because here's the thing about the DevOps space, man. A lot of people just like so easy. Maybe it's not DevOps, maybe it's generally software, because what we do is so hard, right? Like I tell my wife, I walk into the office, then to solve a problem that sometimes nobody's ever solved in the world, and I gotta figure out. That's hard and mentally exhausting, so I get it, right? So and maybe because of that, it comes off as sometimes like as a big troll farm, right? Or just like a big like why Hacker News like flame war or whatever, right?
Absolutely.
So just be considerate, and as hopefully more users kind of use it and everything. Hopefully everybody keeps that in mind. I really like Matt's. Matt's the creator of Ruby. He's really well known for this. It's like Matt's is nice, so everybody is nice. I kind of really like that. It's like just be nice, and then treat others as the way you want to be treated. Essentially.
Yeah, exactly. Yeah, that's really good. I would say final words for today. I think today was the longest and the most informative session which we have ever had on this stream. So I'm really thanks you for your time and 2 hours of your life, which you could have written this framework you just spent on us.
Dude, I appreciate you. And like I didn't get to show the demos and stuff. Whenever we could do whenever, but like a lot of demos actually are using your modules. Like what you've done in the Terraform community is like crazy. Because writing Terraform code takes a long time. Like it's mentally a lot of work. Yeah.
Well, but it's the same as with all other software development. Once you know how you do this, it's kind of fast. So, like, of course, when I started, it was harder. But then I figured out that, okay, it's actually a lot of fun. And I do this much faster than before. So, there is last question from Jesus Malena. Jesus, I guess. I see that Terraspace deals with the top 3 cloud providers, but will OCI be supported or be included? OCI is Oracle, right?
Yeah, it's Oracle. Yeah, I think one day it will be included. I mean, I don't know where it is in the kind of popularity index, right?
I think it's number 4.
Is it number 4? Oh, yeah. Oracle's Cloud's number 4. Oh yeah, so I actually have so there's generators in Terraspace. There's a generator that generates a plugin, and a plugin is a Terraspace plugin, not a Terraform plugin. A Terraspace plugin is essentially the interface that's going to allow you to build kind of basically a support for Terraspace. Okay. So I think I built like AWS and then Google, and then for Azure I was like, you know what, I'm repeating myself, so I'm going to build a generator. So Azure was actually generated, and then you still have to fill in the logic, right? It only gets you like generators only get you so far. You only get like 20 or 30% there. Then you have to actually build the the interface out. So at some point maybe to just to be a front prod, not that high on the priority list right now. But at some point, yeah.
Well, nice. I guess you're also customer driven. So if there will be customer who come to you that we want to use Terraspace with Oracle and we're going to pay you money, then you will probably say, okay, AWS is actually on second place now.
Yes, of course. Yes, that's how I got into Terraspace, right? Yes. That's how I got into Terraform. A customer is like, we want Terraform. I'm like, okay, yeah, sure.
Yeah, it's I see this pretty much everywhere. You don't have to explain. Everyone understands it. Yeah, if you're gonna to sponsor it, that's great. If you just want to request feature request, I will say thanks, but most likely we'll just put it in the drawer somewhere.
Yeah, and see, like, because I'm so excited and passionate about these projects, that I was like, especially beginning, like, oh yeah, I'll do this, and that. and eventually you just get exhausted, right? So you just have to learn how to kind of balance that. And I'm not kind of used to saying that, like, oh no, I'm just gonna put it in my sock drawer or whatever, right? Yeah. But now I'm more kind of used to that, and for what's worth, I think it's healthier for not just me, but because I created this project, it's healthier for overall the project, right? So I appreciate what you're saying exactly. Like I went through that, like it's called open source exhaustion or something, or burnout.
Yeah, I think this is going to be a topic for the next session. Is open source burnout. Or how to abandon projects in open source and still get paid for that.
Yeah, that's a good topic.
Yeah, that's a dream. How to abandon everything and still get paid for that.
Yeah.
Well, okay. Again, thanks a lot. And Jesus just said, thanks for answering my question. So, yeah.
Thanks for having me.
Okay, on this note, we are going to finish, and I will put a lot of information into notes so people can find many of links which we were discussing today. And yeah, remember to click whatever buttons you usually have to click, like subscribe, notification, following. I mean, you all guys know what to do. Thanks everyone.
Okay.
Bye.